This video is actually a section of a course. The name of that course is C Programming for Beginners. This video includes the following lessons. First, what is programming? Logic versus instruction. Second, the role of code, high-level versus machine code. Third, the C language, history, importance, and why learn C. Fourth, option 1, environment setup, macOS Monterey version 12.7.6. Fourth, option 2, environment setup, Windows 11 version unknown. Fourth, option 3, environment setup, Ubuntu, Linux, 24.04 LTS. Fifth, C, Hello World, program, compilation and running. Sixth, anatomy of a C program, main function, libraries, and statements. Okay, let's get started. If you think programming is about solving complex mathematical equations, your idea is mistaken. Programming is fundamentally about logic and clarity, not high-level calculation. So, if it's not math, why do our programs often fail? The answer lies in one key concept: detailed instruction. In this video, we will define programming, and I will show you exactly how to translate your everyday logical thinking into computer-understandable instructions. Welcome to the very first lesson of the course, C Programming for Beginners. What exactly is programming? Simply put, it is the process of writing a set of instructions for the computer to perform a specific task. Your main goal is to translate your logic or your problem-solving approach into instructions or the specific steps for the machine. We'll use a real-world scenario to highlight this difference, helping you grasp this foundational concept. Imagine giving an order to a coffee robot. Your logic might be, "Make me a great cup of coffee." If you say that, the robot fails. It needs instructions. Step 1, add 10 grams of coffee. Step 2, heat water to 90 degrees Celsius. Step 3, pour 150 milliliters of water over the grounds. Programming is the act of converting that vague logic into a sequential and unambiguous instruction set. The computer is the most honest executor in the world. It will never assume or correct your logical mistake. If you instruct it to add 10 grams of sugar and 100 grams of salt to the coffee, it will do exactly that. In code, this means if you write x equals 5, y equals x plus 1, the machine executes those two commands. It will not automatically change plus to just because you intended a smaller result. The programmer's job is to ensure that the human logic matches the computer's instructions 100%. To summarize, programming is translating logic into detailed instructions. The only skill you need is to break down problems into sequential steps. But there's a problem. Human language is different from computer language, binary zeros and ones. So, how do we get these instructions understood by the machine? Click on the next video on your screen right now for lesson 1.02. The role of code. High-level versus machine code. If the video exists. In our last lesson, we learned that programming is giving instructions. But the computer doesn't understand English or any human language. It only understands one thing. It only understands binary code. So how do we, the coders, actually communicate with the CPU? How does high-level code get translated into machine code? In this video, you will grasp the key role of code in solving this complex communication problem. Welcome back to lesson 1.02. Today, we dive into the role of code. To command the machine successfully, you must understand the two levels of language every programmer deals with. Those two levels are high-level code and machine code. Understanding this distinction is key to knowing why C is called a middle-level language and why it remains so powerful. Let's start with the lowest level, machine code. This is the only language the CPU processor executes directly. It's just a sequence of zeros and ones, representing electrical signals. Off, on. If you had to write your entire application using just zeros and ones, you would spend months on one small feature. That's why humans needed a more readable language. Conversely, high-level code is the language designed to be closer to our natural language. For example, in C, you can write int result equals a plus b. High-level code is easy to read and write, but the computer cannot execute it directly. So, how do we bridge this gap? The role of the programming language is broken down into two parts. First, the C language. It provides the strict syntax and vocabulary, like keywords such as integer or for, we use to write clear instructions. Second, the compiler. Once we have the C code, source code, we use a special program called the compiler. The compiler's job is to take that C code and translate every single instruction into machine code, the zeros and ones, that the CPU can execute. The C language is called middle level because it allows us to write high-level code but still gives us excellent control over the machine code, which helps programs run extremely fast. To summarize, code is the bridge, and the compiler is the translator. But why, among countless languages, should C be the one we learn first? To understand the historical reasons why C became the foundation for almost every modern technology, from operating systems to games, click on the next video on your screen to watch Lesson 1.03. The C language, history, importance, and why learn C, if the video exists. After 2 lessons, you might be thinking, C is an old language. Does it even matter anymore? Why not just learn popular languages like Python or JavaScript? Here's the truth. Almost every piece of electronics you use, from the Windows kernel, the iPhone's operating system, to the game engines you admire, all are built on the foundation of C or C++. C isn't obsolete. It's the bedrock of the digital world. In this video, I'll show you why C is the first language you must learn. Welcome back to Lesson 1.03. If you want to become a serious programmer, you need to understand the legacy of C. This is where everything started. C is a general-purpose procedural programming language initially developed by Dennis Ritchie in 1972 at Bell Laboratories of AT&T Labs. It was mainly created as a system programming language to write the Unix operating system. C was a breakthrough. It allowed programmers to write fast, readable code like high-level languages, while still retaining nearly direct hardware control like assembly code. This balance is exactly what made C legendary. C didn't disappear. It lives underneath everything. If you use Windows, macOS, or Linux, you are running a system that is largely written in C. Hardware drivers that communicate with your printer or graphics card, they are often written in C. Even the modern programming languages you love, like Python, Java, JavaScript V8 Engine, or PHP, their core interpreters are written in C or C++ to ensure maximum speed. Learning C is learning how a computer actually works. Why you must learn C first. Reason 1. Memory. C forces you to learn direct memory management, pointers. This gives you deep insight into the stack and heap memory, concepts that high-level languages conveniently hide. Reason 2. Performance mindset. C has fewer built-in conveniences. It demands that you optimize every line of code. If you learn to write efficient code in C, you can write efficient code in any other language. Reason 3. Gateway to system programming. If you have ambitions to work with operating systems, embedded systems, IoT, or low-level AI, C is the mandatory first language. To sum up, C is the historical foundation, the modern backbone, and the best course for forging a professional programmer's mindset. It's time to get hands-on. To start your coding journey in C, the next step is setting up your environment. Depending on your operating system, please choose the appropriate video on the screen right now to set up your environment, if the videos exist. In this video, I will teach you how to set up an environment to be able to program on macOS Monterey version 12.7.6. This video will have 3 parts, but if you want to be different from most people, you can just follow the first part, and then you can leave this video. I think so. We go to the first part, installing the compiler. More precisely, downloading and installing. I will install the command line developer tools, also known as Xcode command line tools. The version that I am using is 14.2.0.1.1668646533. This version includes Clang. Clang is a compiler front-end for the programming languages C. If you learned the lesson 1.02, the role of code, high-level versus machine code, you knew what a compiler is, right? So, how to download and install Xcode command line tools? You can follow this page. First, you need to open this. Second, you type this command. And press enter. I installed it, but if you have not installed it yet, then. Third, you see a thing like this. And you click install and you see a license agreement below has an agree button. I am not responsible for you clicking the agree button. Click agree. So, how do we know if we have had Clang? You can see a complete list of Xcode command line tools by listing the contents of the directory. Go back to the terminal, type this command. Or you may type this command. Remember, we are still in the first part. And if you really want to leave this video after watching the first part. Okay, next, I need to find you an editor. First, you need to open this app. Next, you save. You put your project in the desktop, but first you should to create a folder for it. You name the folder My Project. You change RTF to TXT. You type your C code here. You save. Then you change TXT to C. We go to the My Project folder. This command will show you the items in the folder. You type this command. This command compiles main.c and creates an executable file named main. -o main or -o file, which means write output to main file or write output to file. Okay, you open this to run the program. Or you may run the program with this command. Awesome, right? For first-part people, now you have had the C compiler, a text editor. With this environment, you can code, compile, and run programs, and you may leave this video. Okay, we go to the second part of this video. Downloading and installing a source code editor, specifically Visual Studio Code, also known as VS Code. First, downloading, you go to this page. If you click this button, the file you will get is the universal version. But if you want more specific, you may click this button here. Here, for example, my Mac is Intel, so I may install this. After downloading, I unzip. You may move this file to the Applications folder. This file seems to be safe, so I will open it. We go to the third part, installing some extensions for VS Code. You install this, but if you don't want to install them one by one, you can install this pack. This pack includes those 3 extensions. And you install this. You decide this yourself. To use Clang compiler on Windows 11, you need to install LLVM first. You need to open PowerShell, but you don't know where it is. The easiest way to find PowerShell on Windows 11 is to type PowerShell into the search bar. Here, there are 4 options, so you click this one. Maybe it will work. In PowerShell, you type this command. Then you press Enter. After installing successfully, you can check the version of Clang by using this command. If it shows you a version of Clang similar to this is actually successful. On Windows 11, maybe you can write C code by using Notepad. Like this. Step 1. You write code in a new file, unsaved. Step 2. After writing, you click Save as like this. Step 3. You name it, and you add .c extension to it. You should name it main.c. And below, make sure you choose the All Files option. If you save the file in a folder named Test with the folder path like this, before compiling, you need to move to this folder. In PowerShell, you type cd space path to your directory. After moving, you type this command to compile, and type this command to run. If you want to write code on VS Code, you can see this video 1.4. Option 1. Environment Setup, macOS Monterey version 12.7.6, for reference. To install Clang, first you need to open the terminal on Ubuntu. Here is the way to open the terminal. Follow the following steps to install Clang on Ubuntu. Step 1. Update your package list. You type this command in the terminal, then press Enter. Step 2. Install the Clang package. Next, you type this command. After installing, you can check the version of Clang. You type this command. Maybe your output will show a version similar to this, so it means installing was successful. You can write C code by using Gedit. You can launch Gedit with a new, blank document directly from the terminal with the following command. After writing the code, you save the file, name it main.c. Next, you need to move to the folder that contains the main.c file. After moving, you type this command. This command is to compile. After compiling, use this command to run the file named main. You've set up your tools and you understand the theory. Our high-level code needs to be translated into machine code. The moment you type your code, it's just plain text. It doesn't do anything. How do we make that text leap to life and become an actual running program? That's the missing link. If you didn't run any C program during the environment setup lesson, this is the most exciting lesson. We are going to write the legendary Hello World program. If you don't know, this program will display the text Hello World, and I will walk you through the entire powerful process, from a simple .c file to the moment you see the output appear on your screen. Get ready to run a C program. Welcome to Lesson 1.05. C programming isn't just about typing code. It's a 3-step cycle: writing the source code, compiling and running, executing. We are going to execute each step now. First, writing the source code. Let's open the editor you installed. We will type the classic Hello World program. Don't worry if you don't understand every line yet. The next lesson will explain it in detail. After typing the code, we need to save this file as main.c. We should create a folder to contain the file. The .c file extension signals to the computer that this is C source code. Second, compiling. Now, we need the computer to understand our high-level code. Recall lesson 1.02. The compiler acts as the translator. We will use the compiler named Clang. We type the following command: clang main.c -o main. What does this command mean? Clang is the compiler name. Main.c is the input source file. -o main can be understood as output, and it creates a new file named main. This main file is the executable file that the CPU can read directly. Press Enter. If there are no errors, you will see a new file appear in the directory. That is your program. Third, running. We don't need the compiler anymore. We just need to tell the computer to execute the file we just created. In the terminal, type the command /main. Congratulations! You have successfully run a C program. Recap: you transformed your logic into commands, code, used the compiler to translate those commands into machine code, and finally, the computer executed that machine code. You now know how to do it. Write, compile, run. But you still don't know why it works. What is the meaning of include stdio.h? Why must we have integer main? And how important is that semicolon? Click on the next video on the screen to start lesson 1.06. Anatomy of a C program, main, function, libraries, and statements, where we will dissect the C code and understand its core components. If the video exists, in the last lesson, we successfully ran a C program. You now know how to do it. But if you look at the screen right now, you might still be asking, what is #include? What does int main mean? Why do we need those curly braces? And what is printf, hello, world? Understanding these 4 core components is mandatory before we write any complex code. In this video, we will dissect the C program to understand the precise role of every element, helping you build a solid, foundational understanding. Welcome to lesson 1.06. To be able to write any C program, from simple to complex, you need to master these 4 components. Let's analyze every line of the Hello World program together. Component 1. Libraries, #include, stdio.h. The first component, the library. #include, stdio.h, is a preprocessor directive. It tells the compiler to add another file into your source code. A compiler converts a C program into an executable. There are 4 phases for a C program to become an executable. The compiling we know has actually 4 phases, and preprocessing is the first phase. The file stdio.h stands for Standard Input Output Header. It contains the signatures for essential functions like printf, which we use to print to the screen. In other words, without this line, the computer wouldn't know what printf is. Component 2. The main function main. This is the most critical component. The main function. Whenever you run a C program, the operating system always starts by finding and executing the main function. It is the starting point of your program. The keyword integer before main means this function will return an integer value back to the operating system. Component 3. The code block. The code block, defined by the pair of curly braces opening brace and closing brace. This block is like a room that holds all the instructions you want the main function to execute. Component 4. Statements and semicolon. This line, printf, hello, world, is a statement. It is a complete, specific command to the computer. Print this text to the screen. And here is one of the causes of errors. The semicolon, winky face. In C, the semicolon is used to terminate a statement. It is exactly like the period that ends a sentence in English. You cannot forget it. This is the final statement in the main function. Return 0 means return the value 0. This value signals to the operating system that the program has finished successfully, without errors. In summary, these 4 components form the skeleton of every C program. If you understand this structure clearly, you are ready to move into Section 2. We have the skeleton. Now we need data to manipulate. Click on the next video to start Section 2, Fundamental Concepts, with Lesson 2.01, Variables. Concept of variables, declaration, and initialization, the most basic concept in every programming language. If the video exists,